Hello and welcome to another Arlington High School Math 4 Honors lesson. My name is Kirk Weiler, and today we'll be doing Unit 2, Lesson Number 1, Functions and their Notation. The entire second unit is really devoted to background information that is review about functions. Functions are one of the most important mathematical tools in all of math. So let's start this lesson by reviewing what a function is. All right. A function is any rule typically given in the form of an equation, right? A graph or a table form that converts an input value, also known as the independent variable, to an output value, also known as a dependent variable. Oftentimes people kind of look at this as x goes into some function and a value of y comes out, right? Only one, or better yet, at most one, because there might be some values of x that we put in that don't give us a y out. All right? So what we're going to be working with today is function notation and a bunch of other ideas. Make sure to have your calculator handy for the last problem that we do, but let's get right into it. I'm going to clear this out. All right. Exercise number 1. The variable y is a function of x, also known as y equals f of x. You'll see this a lot. Now, by the way, I want to point something out immediately. Y and the function are the same thing. That's what that equals symbol means, right? They're the same thing. All right? And it's given by the equation y equals f of x equals 2x squared minus 1. Answer or find the following. All right. Now, my bet is that you should be comfortable enough with function notation to completely do letter A, to at least start letter B, but let's hold off on letter C for a moment. So why don't you go ahead and try A and B by first pausing the video. All right. Well, function notation, which we're going to really need to master at this level, says that whatever goes in here substitutes in for the independent variable. So f of 3 is going to be 2 times 3 quantity squared minus 1. We just have to remember our order of operations. That exponent comes before the multiplication, so we'll get 18 minus 1, or 17. Now, letter B is extremely, extremely important, okay? I don't care what's inside of this parentheses. I don't care how weird it looks, how strange it is. That needs to replace the input variable, and everything that's done to the input variable, needs to be done to whatever is sitting inside of the parentheses. So, what's being done to the input variable? It's being squared. So that's the way we start. Quite frankly, I'm okay if you leave it like this. I mean, everything else is just algebraic manipulation. What I'm not okay with, so if you're one of my Math 4 Honors students, is saying, oh, well, that's just 2x squared minus 1 plus h. That is completely and utterly wrong, all right? So we have to be very wary of that. Now, again, you could still do some algebraic manipulation on this, but nothing about the problem states that you have to. In fact, that would be x squared plus 2xh plus h squared minus 1. And the only reason I'm doing all this manipulation is in case you did it and you wanted to see if what you had was correct. But technically speaking, f of x plus h is this, or it's this, or it's that, right? It's lots of different things. Now, letter C is a little bit different. It says, you know, we're going to find the values of x for which f of x equals 71. Now, this is very, very important. You know, even students at a high level can look at that 71 and go, yep, I'm plugging that in for x. But in fact, this is the output, right? It's the output. It's the y value. So what we want to do is actually solve this equation. All right? Pause the video now, take a moment, and go ahead and solve that. Should be pretty easy. Okay, well, hopefully you got plus or minus 6. This is a situation of an equation where x only shows up once, so I get 72 equals 2x squared. X squared is equal to 36, and x must be plus or minus 6. Hopefully you add both the plus and the minus. If you have only the positive 6, well, then we're still missing something in terms of solving quadratic equations. Okay, well, pause the video now and write down anything you need to before we go on to the next exercise having to deal with functions. Okay, I'm going to clear out the text, and let's move on. Now, up front, when we were looking at the definition of a function, we said, well, a function can come in equation form, graphical form, or tabular form. In this case, we have a function, g of x, that is given in terms of a graph. Now, letter A is definitely review, as is pretty much the entire worksheet. It asks, how can we graphically tell that y is a function of x? There's a quick check. Do you remember what it is? All right. Well, the quick check is that it passes the vertical line test. All right, and what was the vertical line test? The vertical line test was that if we took any vertical line, here, let me go with something red, all right, and we drew any vertical line, then that line hits the graph at most one time. So any of these vertical lines I draw are going to hit the graph only once, all right? Now, it's my great hope, of course, that you understand why the vertical line test works, and certainly at the Math 4 honors level, it's my expectation that a student would be able to explain the test, right? And it's very, very simple. What you really have to do is explain the counterexample. In other words, if I had a graph that looked something like this, all right, and I drew a vertical line, then what that would mean is that for whatever this x value is, right, because along a vertical line the x value doesn't change, there would be two y values. But the most basic definition of a function is that for a given input, x value, there is at most one y value. All right, so if it hits it twice, there are two y values for that x, and now we don't have a function. All right, and now I got to erase all this stuff. Otherwise, we're not going to be able to see anything. All right, so vertical lines are gone. All right, let's take a look at letter B. Evaluate g of 7 and g of negative 2. See if you can do this. Pause the video and do it pretty fast. All right, well, it's pretty easy. If we've got something like g of 7, what we're literally saying is the input, x, is equal to 7. We want to know the output. 1, 2, 3, 4, 5, 6, 7. And it looks like the output is 2. G of negative 2 is a little bit more challenging because when we go to negative 2, we've sort of got these 2 points. But remember that an open circle means that it's not there. Okay, an open circle doesn't count. All right, or it's not defined there. So G of 2 is equal to positive 1, right? That's the actual y value. Now, letter C is actually asked in a very different way. It says, how many values? It doesn't ask what they are. It asks how many values solve the equation g of x equals negative 4. Well, pause the video right now and think about this, and also think about how you might illustrate it graphically. Okay. Well, again, what they're saying to me is that my y value is negative 4. And a great way to actually get a sense for that is to draw a horizontal line. Horizontal lines are lines where the y values are always the same. So all along that y value, all along that horizontal line, y is negative 4. So we have two values, right there and there. I'm not going to try to determine what they are, but they're there and there. All right, finally, state the domain and the range of this function using interval notation and label. Okay, so we got to talk about these two very important terms, the domain and the range. All right, I don't want to write these out longhand because you've seen them before, but the domain typically students think of as the x's, and the range they think of as the y's, and that's not bad. You know, it's not a bad place to start. It's not a very workable definition, and what I mean by that is that the definition, oh, the domain is the x's, doesn't do any work for you. Likewise, saying that the range is the y's, that doesn't do much work for you. So how about this for domain? Domain is the set of all inputs that then result in a real number output. All right? It's the set of all inputs that result in an output. So the smallest x value that gives us a y value, 1, 2, 3, 4, 5, 6, 7, is negative 7. And the largest is 1, 2, 3, 4, 5, 6, 7. 7. The way interval notation works is that we use these brackets, right? We could, if they didn't say interval notation, we could also list it like that. Now, it's not just about finding the min and the max, though, all right? The min and the max x values. It's also making sure that we didn't skip any x values in between. So again, the only one that's really worrisome is that x equals negative 2, right? This guy right here. But we do get a y value for that. We get a y value of 1. So it all works out. Now, the range in this problem is considerably trickier. Now, again, a lot of students think about the range as being the set of y values. I think of the range as being all values for which there's an input that results in that value as an output. Wow. Okay. In other words, a value of y is in the range if there's a value of x in the domain that gives you that y value. Okay? So think about what the range of this function is. It's trickier than the domain. All right, well, let's take a look. We can think about mins and maxes right away. So for instance, 1, 2, 3, 4, 5, right? Y min is equal to negative 5. But y max, well, I don't really have a max y, right? I mean, I don't have a maximum y because 1, 2, 3, 4, 5, you know, that y value is getting very close to 5, but it doesn't actually hit it. That's what that open circle does. So a lot of people will just say, all right, no problem. Yeah, it goes from negative 5 to 5, but we'll just put a parenthesis there. Unfortunately, that's not correct as well. And the reason it's not correct is because there's a whole slew of y values that lie between this one and this one that were never hit. All right? So actually, the correct way of saying it would be, well, we go from negative 5 all the way up to 1, and we do hit 1, right? We hit it right there. And then union 2 all the way up to 5. And again, we never hit that 5. So this is the correct answer. And it's quite tricky, quite tricky. All right. Well, pause the video now. Write down anything you need to. All right, I'm clearing out the text. Let's take a look at one involving a table. All of these you're going to have to be able to deal with all different representations, the equation, the graph, and the table. Each has its own benefits. Each has its own detriments. You know, the beautiful thing about an equation is you can really get everything from it. But it's hard to get stuff from it. You have to do calculation, you have to do solving, etc. The beautiful thing about a graphical representation of a function is you see everything right there. It's right there. But it's harder to get exact answers, perhaps. Finally, in a table, tables are great. Tables are wonderful because it's all just sitting there, except it's not. Tables always give us an incomplete picture, right? Because we're missing stuff in between the times, or in between, in this case, the Celsius temperatures. But still, it's pretty basic. It says the Celsius temperature of a particular chemical reaction is a function of the time since the reaction began. C equals F of T. For a particular reaction, selected values are shown below. And the first thing they do is to ask us to evaluate F of 20. Well, that's not so bad, right? This is the input, which is time. And when the input is 20, the output is 58. I like that. Now, letter B says, well, let's solve where F of T is equal to 30. In other words, I want to know the T values that I'll put in that will give me an output. Again, that's an output or a Y value of 30. Well, let me just change color really quick. Here's an output of 30. Here's an output of 30. And I just have to look backwards and see that T must be 7 and 30. All right, letter C. Why can the temperature be thought of as a function of time, but time cannot be thought of as a function of temperature in this reaction? You see, sometimes when we're relating two variables, which one is a function of the other is not necessarily clear. All right, the distance that I've driven is a function of how much time I've driven. But how much time I've driven is also a function of the distance I've driven. On the other hand, here, the temperature is definitely a function of time, but time is not a function of temperature. So think about why that is. How would you explain it? All right, well, let's take a look. Essentially, to explain this, we just have to spit out the definition of a function. Watch. Ooh, in red. Temperature is a function of time because for each time there is only one temperature. And that makes sense. I mean, we're talking about a chemical reaction here. If I measure the temperature when T is equal to 12 seconds, I can't get two values. There's only going to be one value. On the other hand, time, that's weird. Weird place for an E. Time is not a function of temperature because for a given temperature, there could be more than one time. And a great example, when C equals 30, T equals 7 and 30. All right, so that's it. Very, very important to know the basic definition of a function. All right, let's keep going. One other thing I wanted to cover today was the concept of average rate of change. So let's take a look at that. When we study calculus eventually, calculus will be the study of change and how fast things change. But when we study how fast a variable changes, we are always actually comparing how fast two things change. Typically, we're comparing how fast the dependent variable changes compared to the change in the independent variable, which is often time, but it doesn't have to be that way. So the average rate of change is very simple. If we're given a function f of x, and we want its average rate of change, then we calculate that. Whoops, that didn't work. Let me just scribble a little bit more. Then we calculate that by simply finding how much the function changes over the interval versus how much the independent variable changed over the interval, right? And of course, this is just the slope formula, because slope is a particular type of average rate of change. But all we're doing is comparing how much the dependent variable changed to how much the independent variable changed by using a ratio. And that's often what ratios are used for. All right, so let's get into that. I'm going to clear this out. All right, for the function f of x equals root x plus 8, find the average rate of change over the interval 1 to 8, given an interpretation of the value you calculate. So this is pretty easy from a mechanical perspective, right? I'm going to do f of 8 minus f of 1, all divided by 8 minus 1. Of course, that means I have to figure out what those things are. F of 8 will be the square root of 8 plus 8, square root of 16, which is 4. And f of 1 will be the square root of 1 plus 8, square root of 9, which is 3. Now, really what this means, if you think about it, whoops, not that, if you think about it, was that the function, the change in the function, was 1 unit. I mean, yeah, you can do the subtraction, but again, as I go from here to here, right, we added 1 unit. And sure, that's f of 8 minus f of 1, but don't lose the forest for the trees. Ultimately, I just wanted to know how much the function went up or down. Of course, delta x is negative, it went down. And, of course, the change in x is 7. Now think about that. What that means is, and here's my interpretation, on average, over the interval 1 to 8, f increases 1 unit for every 7 units of increase in x. So it's a simple interpretation, right? That slope of 1/7. Now there's some key words, by the way, in this explanation, and I want to make sure that we note them right now. On average, that's very important. Over the interval, discuss the interval, increases, etc. Increase. So in other words, on average, I don't want to just say, hey, the thing increases by 1 unit for every 7 units of increase in x. It's an average rate of change. All right, we'll get into more how to differentiate that from what's known as an instantaneous rate of change, but it's an average rate of change. So on average, on that interval, we got to state the interval. On that interval, f increases 1 unit for every 7 units of increase in x. All right, I hope that made sense. Pause the video now. We'll clear it out. We'll do one more exercise. Okay, here we go. All right, in this last exercise, we've got a population of rabbits on a tropical island is modeled by the formula P equals f of t times 126e raised to the 0.2t. Calculate to the nearest whole number the average rate of change of the population over the interval 5 to 10. Include appropriate units in your answer. That's actually, that last little piece is a little bit tricky because I never told you the units of time. Let's say time is in terms of years, okay? Years. So what I want to do is, it's simple enough. I want to do f of 10 minus f of 5 divided by 10 minus 5. But I'm going to show you a really cool thing on the calculator right now, okay? So I'm going to open up the TI-84 Plus, and hopefully I'm going to show you something new. See, your calculators have the ability to use function notation. Isn't that remarkable? I always think it's a little bit odd that we don't show that to students earlier, but now we're gonna use it, okay? Now, I'd like to actually show you how the calculator does this, though, with a simpler example, okay? So let me show you. All right, what I'm going to do is I'm going to go into y equals, and I'm going to put in a function. Now, right now in my y equals, okay, I'm in it. Right now, I've got y1 equals 2x. I want to keep a simple function, then we'll go to the 1 in this problem. I just want to show you how this works. So what I'm going to do is I'm going to get out of y equals now. I'm not going to graph that at all. And I'm going to show you where you can sort of get the function notation. So here's what you're going to do. You're going to find this button right up here. It's called the vars button. And you click on it. Now you go one option to the right to what's called y vars. All right, and we click on it. Then I go down a couple spaces. I'm sorry, not even a couple spaces, but I go down one space to get function. All right, because I want the function. And then under that, I grab y1 and I hit enter. I know that's a lot of keystrokes, right? Vars, y vars, function, y1. But now I'm out on the main screen. Now watch what I'm going to do. I'm going to put in the left-hand parentheses, and I'm going to put in 5 and the right-hand parentheses. And watch what it gives me. Let me hit enter. Look at that. It gave me 10. Now remember, my function was 2x. So this thing actually knows function notation, which is really, really cool. Because if we have a slightly messier formula, like we have in this problem, then we can put that in as y1, and we don't have to worry about the messy calculations. So let's do that. Let's hit the y equals button again. I'm going to clear out my 2x, and then I'm going to put in my function. 126 times e caret for raised to the 0.2, and I got to use x, but that's okay, x. All right, parentheses, enter. All right, so look at that. So we now have my function in there, 126 times e to the 0.2x. So let me get out of here. I'm not going to graph this, okay? I'm just going to get out. And now what I'm going to do is I'm going to do the numerator, just the numerator. I'm just going to figure out what this is. All right, so I go into vars, yvars, down to function. All right, stop here for a second, and then I hit enter. And now I'm going to put parentheses, 10, parentheses. Now, if I hit enter right now, it would literally tell me what the population of rabbits was on the tropical island after 10 years. I'm just looking for the average rate of change. So I'm now going to put minus, and then I'm going to do the whole thing again. Vars, yvars, function, grab y1, parentheses, 5, parentheses. Now I've got y1 of 10 minus y1 of 5, and that's exactly my numerator, so I hit enter. And now to get my final answer, I just do divided by 5. You know, if it was more complicated, we could do like divided by 10 minus 5, but it's not. Now, remember, I round to 3 decimal place accuracy, so that's 117.704. And let's talk about units. Units are important. The units of the numerator are the change in population, and that population was in rabbits. The change in the denominator was in changes in hours. Oh, not hours, years. My mistake. Almost a good mistake to make. Years. So, what we get is 117.704 rabbits per year. Not years, per year. All right, and that's it. Isn't that a cool trick? All right, I think I'm going to clear out the text and the calculator all at once. Watch. I think I can pull this off. But pause the video now, write down anything you need to. All right, I'm going to get rid of it. Here we go. Text is gone, calculator's gone, we're all set. All right, let's wrap up the lesson. So today we refreshed the basic idea of what a function is. It's any rule given in an equation, graph, or table form that takes an input, typically called x, but very often called t in this course, t for time. It takes an input and it gives us at most one output. So we can't have more than 2 outputs for a given input. All right, and we looked at this from a variety of different perspectives, you know, from the perspective of having an equation, from the perspective of having a graph, from the perspective of having a table. The other thing that we covered today was a review of the average rate of change formula. That's going to be a very, very important formula for when we think about how fast the dependent variable, the y variable, is changing compared to the x variable. All right, well, that's it for now. I'd like to thank you for joining me for another Arlington High School Math 4 Honors lesson. My name is Kirk Weiler, and until next time, keep thinking and keep solving.